Welcome back, everybody, and thank you for your patience to those who have been waiting. We now turn to panel 2 on AI in the nuclear sector, today, tomorrow, and beyond. This session explores how artificial intelligence is transforming nuclear operations, from predictive maintenance and performance optimization to advanced analytics and safety applications. We'll look ahead to future innovations and the protections needed to ensure AI enhances reliability and trust. To set the stage, please join me in welcoming Ms. Maria Korsnick, President and Chief Executive Officer of the Nuclear Energy Institute. Drawing on her engineering background, hands-on experience in reactor operations, and a deep knowledge of energy policy and regulatory issues, Maria Korsnick aims to increase understanding of nuclear energy's economic and environmental benefits among policymakers and the public. Before NEI, Maria Korsnick served as Chief Nuclear Officer and Acting Chief Executive Officer at Constellation Energy Nuclear Group. Please join me in welcoming Maria.
Well, thank you so much for those kind comments, and good afternoon. It's a real pleasure to be with you today and to be a part of such an important conversation. As she mentioned, I run NEI, and it's the leading policy and technical organization in the U.S. commercial nuclear industry. We represent more than 350 members, and they range from uranium miners, to reactor builders, to public utilities, to tech companies. And on behalf of all of our members, I've had the opportunity to connect with public and private sector leaders around the world. Really, in just the past few weeks, I've spoken to audiences in South Korea for the Asia-Pacific Economic Cooperation Summit, in Greece for the Partnership for Transatlantic Energy Cooperation, and in France for the World Nuclear Exhibition, and now I'm very honored to be here with you today. I've heard many different perspectives across many different countries, but in each of those rooms, there's one thing that everyone agrees on. AI is transforming the world and redefining the energy industry. Spending on data centers, as you heard in earlier presentations today, that will power our AI future is expected to reach $580 billion worldwide this year alone. Globally, the power they demand is expected to increase 50% in the next 2 years, and more than 150% by the end of the decade. Leaders in government and business have realized that to meet this exponential demand, our energy future simply must include nuclear. And that's because they increasingly appreciate that the only form of energy that's clean and reliable 24/7, 365 is nuclear. The relationship between AI and nuclear has the potential to not only be catalytic, but truly symbiotic. Few technologies hold more promise to enhance how we do business than artificial intelligence. To us in the nuclear industry, AI represents exciting opportunities to complement and improve our long-established practices. AI is allowing us to build on our strong foundation by improving safety, efficiency, and performance. By applying AI with a focus on transparency, regulatory compliance, and operational integrity, the industry can really unlock its full potential. There's so much that the nuclear industry can do to power the AI transformation, and there's so much that AI is doing to make the commercial nuclear industry safer, more efficient, and more innovative. I've heard stories from our members about how AI is already allowing engineers to focus on more higher valued work. Instead of spending hours sifting through documents, they can dedicate their time to what's most important, and that's generating new insights and finding real solutions that can make our industry safe and reliable. There are countless ways that our industry can leverage AI. Engineers could use AI to improve plant designs. Operations experts could use AI to identify issues, understand their potential impact on plant operation, and strengthen maintenance protocols. Plant leaders can use AI to troubleshoot equipment issues and find solutions much faster. And on top of that, NEI is working on a knowledge management system now to help train people and make them more proficient faster to meet the huge demand that we're seeing for nuclear. The more we innovate, the more concrete we pour, the more reactors we bring online, the more data centers can be built, and the more innovation can accelerate. And here's the catch. We have to keep this cycle of innovation spinning by turning conversations into collaboration and partnerships into progress and commitments into action. Today, we're going to discuss how we can accomplish that. This panel will begin by sharing our experiences of AI solutions that are already being deployed in the nuclear sector, including the strategic decisions, the challenges, the benefits, cybersecurity measures, and lessons learned. The discussion will then move on to near-term solutions that we expect to be deployed in the next 5 years and conclude with a longer-term vision for AI in nuclear. I'm looking forward to discussing where we are and what's ahead. Thank you to IAEA for organizing this symposium on such an important topic. And now I will join Lisa and my fellow panelists. Thank you.
Thank you so much, Maria. And you talked about the potential, also what we're already seeing, increasing productivity. You're talking about some of the topics that we'll really start to unpack in this panel. I really like what you said about keeping the innovation cycle spinning and the focus on collaboration as well. So joining us for the panel are Mr. Aurélien Schwartz, who is the CEO and co-founder of Metroscope, a company specialized in AI-applied nuclear power plant online monitoring. He began his career as a researcher at EDF, and he will be presenting real AI use cases in online monitoring applications, discussing the current limitations of AI technology and its acceptance, and examine the long-term positioning of AI in NPP operations. Aurélien. I'm also pleased to introduce Mr. Trey Lauderdale, the CEO of Atomic Canyon, a leading provider of AI-powered search and generative AI tools for the nuclear industry. A proven entrepreneur in highly regulated industries, Trey Lauderdale previously founded and led Voalte, a healthcare communications pioneer acquired by Hillrom, and he was an architect for Hillrom's digital growth and sale to Baxter. He earned degrees in industrial engineering and entrepreneurship from the University of Florida. Trey? And our fourth panelist is Mr. Sid Crowley, who's an advanced nuclear lead at DigiLab Solutions in the UK. Sid has a deep background in physics for energy, trained at Imperial College London, and he holds a PhD from the York Plasma Institute. Sid leads the Advanced Nuclear Solutions Group at DigiLab, bringing uncertainty-aware AI to challenges in nuclear, from design to decommissioning. Sid advocates for more standards and trust in AI for nuclear as the chair and founder of the Fusion Industry Association Digital Committee and a contributing member of the IOP Working Group on AI for Physics. Sid, thank you. So, let's begin, if we can, please, by looking at where AI is already making an impact across the nuclear sector, or even beyond the nuclear sector. And as you said, Maria, then we'll move toward what needs to happen to scale these innovations within nuclear responsibly. So maybe I can start with you, Maria, since you already kicked us off.
Sure, no, happy to. And I don't want to steal Trey's thunder, but Trey and I are working on something together, and so part of that is already, I'll say, in testing phase, and we're deploying it. So I guess, Trey, I want to give you maybe the big bang for the buck. I'll let you describe it in more detail, but I can just say we're working on a module that helps us with knowledge management and helping people get trained and up to speed faster. Already in power plants, AI is being used, I would just say, to help reduce I call it administrivia, but administrative tasks and work that have to, like the corrective action program has a lot of heavy sort of databases, that you have to go through. And something like AI can really kind of cut through a lot of these process things that in the nuclear industry, we're just used to, that's how you get the work done. You follow this procedure and you go through all these steps. And I think AI is just a wonderful way of kind of cutting through some of that drudgery and then sort of just bringing to the fore, okay, well, here's where you need to pay attention to. Here's where you need to put your mind to. So I think the most beautiful thing for AI is that the nuclear industry being highly regulated, we're very information intensive, we store a lot of information. We're like the poster child for why AI can be helpful, because it can really go through a lot of that information and then kind of bring to your attention, hey, this doesn't make sense, or this doesn't look right, or here's the trend that's off, or why does something look like this? So the human is still doing the thinking, if you will, making the choices, kind of thing, but you don't have to spend all that time going through the information. In fact, I would say probably in some cases, some of the plants that we have, their information might not even be digital yet. I mean, think about, I can think of the plants that I've worked at for many years. They still have stuff on microfiche that you'd be going back through, looking at some design drawings, on microfiche. So I think, one of that first, once you appreciate the power of AI, I think it really drives, I want AI to have some access to this so that it can do the things that I'm asking it to do. So maybe that's enough as a sort of a kickoff.
It's a great kickoff. Thank you. And you mentioned that Trey has something to share with us. I want to.
Well, now I have to jump straight to that, huh, Maria?
I think we need to know.
So I think maybe baselining before we jump into, the opportunities for AI in nuclear and how it can impact power plants and others. There's a lot of optimism and excitement from all the speakers, which I think is very well-founded, because artificial intelligence has tremendous opportunity to transform every aspect of nuclear. But I'll first start by saying, and maybe we're the realist panel here, it is incredibly hard to get AI to work accurately in the nuclear power industry. And I don't say that to, convince people not to do AI. We absolutely should, but people need to realize, and many of you do, nuclear is based on precision, reliability, accuracy. AI, especially the latest form of AI, these large language models, does this thing in the AI community we call hallucinate. That is a very cute word, hallucinate. In scientific terms, that's when AI makes beep up. It just makes stuff up. Hallucination and nuclear power does not mix. This is a bad combination. So, stepping back, there's excitement around AI and what it can do in nuclear, but there's a lot of infrastructure that needs to be put in place. There's benchmarks, rigor, work that needs to be done to make AI usable in specific nuclear workflows. So to Maria's comment, I first have to say a huge kudos to you, your leadership. A few organizations in the United States got together, NEI being one, INPO, the Institute of Nuclear Power Operations, and EPRI, and they realized we have these really powerful data sets. There's all of this knowledge, information that we should be able to share with our members. However, the tool sets to search and harness that knowledge from this information and data set are somewhat challenging. In some cases, I won't say whose it is, there's like Boolean search. It's like search equals this, period, dot, dot, exact words. So the partnership that we've struck is all about building, the name has recently changed. It is now the Nuclear Industry Virtual Assistant, multiple modules that we're building in partnership with NEI, with INPO and EPRI. Kind of the first two that we're bringing out is a knowledge assistant. So there's all of this information from these different sources. You want to be able to ask questions and then get reliable answers. And then most importantly, you want citations that say, I, the AI, am giving you this response, and this is exactly where I pulled the data from. And guess what? It won't always be right, but you can go and validate, and then you can say thumbs up or thumbs down and create a reinforcement loop. The second is operating experience. So events happen at the nuclear power plant. Some of the plants we partner with have billions of pages of documents. Most of it's digitized. There still is some microfiche out there, but so mostly digitized. When an event occurs, you want to go and find out what other power plants throughout the United States or world have had that event occur, and what are similar learnings I can find, because there's probably something relevant to what I'm doing. So in partnership with these organizations, these are sets of generative AI products. I don't like to call them AI. I mean, it really is just democratization of knowledge more than anything else. But it's a great example, again, of thought leadership from NEI, INPO, and EPRI to say, we should be building standards together, not running in our own swim lanes. And just today, we did a signing with IAEA that we're going to be doing a similar type partnership with them. So for us, it's all about getting access to the data sets and making that available as a foundational layer as we look at building more generative, advanced, creative use sets.
Thank you. Thanks for sharing. So Aurélien, can you share your perspective on AI for nuclear?
I can definitely do that. My perspective will be slightly different than yours because you applied AI to knowledge management. I apply AI to time series to do online monitoring of nuclear plant in operations. And Raphael Grossi this morning introduced the session saying that it's about atoms for algorithms. Well, my job is to do algorithms for atoms. So this is the other way around. And so our key goal is to try to understand, okay, how do we provide value to existing nuclear plants through AI? That's really the reason of being of Metroscope. And so the startup is, I want to share a little bit about the entrepreneurial story. I think it's of interest. I used to be a researcher working in EDF laboratories, working on probabilistic approach, how to manage all the uncertainties, all the noise that we see on industrial data. And we came up with that idea that if you use a model with the physics or even a machine learning model, essentially you have, like, for one set of boundary condition, you have one outcome. The problem is uncertainties are all over the place. It's very noisy. And so you never have something as clear as one set of boundary condition, one output, I go for it and I can make my decision. That doesn't work that way. So what we did is very early on, back in 2016, we developed an inferential engine that's based on Bayesian theory. That's part of AI. That's everything related to doing real-time root cause analysis on complex systems. So we used Bayesian theory, and we built that Bayesian inference to try to actually leverage that deterministic model that we had with a probabilistic engine, eventually to say, this is what we think is happening. And we didn't know even at that time that what we just designed was what is now called a digital twin. Literally, it's an expert system where you have a model on one side, an inferential algorithm on top of that, and you build a user experience around it, and eventually the goal is eventually to say, okay, what is happening on my plant? That is the one question that we're trying to answer at Metroscope. What is happening on my plant? So how do we do that? Well, if you look at a nuclear plant, you have like a lot of complexity. We all know that. And relatively to the complexity of the nuclear plant, you don't have a lot of data. You have a lot of data in absolute, but not relatively to the complexity of what you're looking at. Most of the problems that happen on a nuclear plant, they happen like once a decade. So what is that data? Like once a decade. How do you build machine learning, strong machine learning approaches with something that happens once in a decade? You don't. The easy answer, you don't. So what do? You need to embed expertise. You need to embed the physics. That's the basics of expert system. That's the basics of AI that we are currently building. So how do we do that? Well, we look at all the measurements that are available on the plant, and we look at the design plans of the plant. And then we will create a model out of that with all the physical equation embedded. Like any model, any digital twin is like 12,000 physical equation. It's a lot. For 250 data sets, that's very low compared to the number of equations that we have to build. And on top of that, we extrapolate all the failure mode of the plant. We put that in a big matrix and we say, okay, this is the inward causality. If I have a problem, through that model and that matrix, this is the consequence. No, looking at the data, give me the consequence, I will get back to the cause, which is real-time root cause analysis, which is eventually the goal of a digital twin. And when we do that, and EDF was the first customer of us to deploy Metroscope on a full fleet of assets. They have 56 nuclear plants. Stéphane Dupré-Latour this morning was on stage speaking that they won 100 megawatts out of just using that real-time technology out of 56 nuclear plants. So it's very much real, you know, and it's providing a lot of value. And where does that value come from? It comes essentially from the fact that people can trust the results of our technology, so they can actually make a decision afterward. They can literally say, okay, if the algorithm is telling me, I know that I can go to my maintenance committee, I can defend that maintenance, I can fix the plant, and I'm right 97% of the time.
Fantastic. Well, thank you for sharing that. And I'll turn to you, Sid, to complete the opening remarks on where
Sure. And it might be good to end this by saying, or leave this opening question by saying, we definitely see the future of AI and nuclear, or how it's used presently as well, as containing those kind of two pillars that we've overviewed. I mean, from one perspective, nuclear, we all know one of the biggest problems with nuclear is that it's expensive, right? It takes a lot of capital to build, and a lot of that expense comes from complexity, right? There's just so much information involved with designing, building, and decommissioning a nuclear plant, and as you said previously, I mean, the use of information models, language models to cut through that information and allow people to work more efficiently through that information is a huge use case for AI infusion. But at Digilab, we also work on the other side, the more, let's say, technical AI side. Nuclear is also a very technical industry in which many, many very technical calculations are done by scientists and engineers, and as we said, they need to be precise, they need to be reliable. And certainly AI can help on that side a lot as well. At Digilab, we are a SME based out in the UK. We work a lot in the advanced nuclear industry in the UK. And I guess one of the use cases that we work on that I just add to the discussion is sort of numerical or technical AI to optimize processes, but optimize more technical processes. So for example, at the design stage, using things like probabilistic surrogate models to speed up simulations, and using those simulations not as the sort of end-all simulations that you go away and trust and use sort of later down the line, but maybe exploratory early design. And for some use cases in sort of the nuclear sector, we've taken, you know, FEM simulations or advanced fluid simulations. We've made them faster by a factor of about 10 million times. So when it used to take maybe days or weeks to do a really, really high fidelity simulation, now you can do maybe thousands of them in a week. And so you can really either scope out a design space for optimization very quickly, or you can do things like sensitivity analysis. You know, if I have a bit of uncertainty on an input design parameter here, how does that affect the end performance of a component I'm building? So that's the one thing I think I'd like to offer to this conversation is, you know, a numerical or technical AI to sort of optimize engineering processes, and doing that in conjunction with engineers, sort of giving them visibility over the tools, the AI tools that we're using.
That's great, thank you. And I want to circle back to those early applications in a minute, but because we've been talking about trust and hallucination, and for anyone who's used AI to do anything, you get very frustrated when it starts to hallucinate and it's not giving you what you expect it to give you. But so as individuals, I think we're concerned and we're skeptical about the safety of AI, and especially when it comes to nuclear and the data that we're providing it, right? So how can we be reassured that the solutions that you're talking about and other solutions may be implemented safely in the nuclear space? So I don't know if anyone wants to try to tackle that. Sid, you want to kick off, and then Maria?
So I'll offer one perspective, which is the importance of uncertainty quantification. I hope we're really sort of nodding your head as a Bayesian statistician. But and the reason why is this. I mean, maybe as a show of hands, how many people would trust ChatGPT for a sort of factual piece of information for their job? Anyone?
We can't see.
Okay.
Not very many.
Probably good. But even if you think so, probably don't, just in case anyone sees you. But the point is, a lot of us don't. Why is that? Is that because it's wrong? And I would argue not necessarily. I think it's because it's confidently wrong. And I think a lot of us have that experience with ChatGPT or other language models where we go, ChatGPT, what is the population of Vienna or something like that? And it goes, it's 1 million for sure. And you say, well, I found this other source that says it's sort of 3 million. And then ChatGPT goes, oh, yeah, you're right. Yeah, it is 3 million. Sorry about that. And you go, well, why were you so confident when you said it was 1 million? And I think it's the same for trusting people, for trusting anyone. We all make mistakes. We're all wrong. But it's about being appropriately confident with the answers that you give. And so I would trust a ChatGPT if I asked it what the population of Vienna was, to say, I found some sources that say 1, some that say 1.5, some that say 1.8, but I really don't know. And it's that raising your hand when you don't know that I think is one of the hugely important aspects for building trust for AI.
Thank you. Maria?
Yeah, I think, partly you kind of have to know what you're getting into. We've mentioned hallucinations and ChatGPT, and well, that's because it's going off and it's kind of, searching the world of information that's out there, right? But you can create other ways, right, of using AI. I mean, you can give it a handful of documents and say, this is what I want you to go through. And some examples that we use in nuclear today, for example, is, you can give it all kinds of regulatory documents and you can say, hey, write me a requirements, a summary based on all of this technical information that I'm giving you. And so, it's not sort of going out and searching the World Wide Web. It's searching, a handful of technical documents that you've provided it. And in fact, it's an area that we're just unveiling this probably this month or next, and that is, it's called Reg Checker. And so it's an opportunity for, if you're going to submit something to your regulator and you want to have a quick check of that, you can say, well, here's the thing I'm submitting, and here's all of the regulation that applies to this thing that I'm submitting, and give me your evaluation. Did I answer all the questions? Or some of these regulatory requirements that are required of me, but you didn't see that so much in my answer, and it gives you a rating. Really good at this one. Hey, this one's a little light. You're light on this. Go look at that. And so, but it does it in 5 seconds or something. And so again, I go back to, this isn't writing the human out of the equation. This is putting the human in the position to say, hey, listen, you know what it is that you're trying to do, and I'm just going to do a lot of the drudgery work, and then I'm going to give you the problem statement, and then you can say, I don't think you answered this question very good. I'd go back and look at this again, but you need to go do that. And so I think it depends. All AI isn't created equal. It depends on the boundaries that you put. And I think as we look ahead, it's not trying to get the human out. It's trying to put the human in a more decision-making, let me clarify the role that you need to play, and not have you spend the next day and a half looking through documents before you get started.
I think I can complement on that by bringing another concept that is extremely important to us, which is explainability of the AI. Because every time we bring diagnostics to operational people, we always give them the reason why we think this is happening. I mentioned earlier, we use a big linear matrix with all the failures of the plant in it, and we purposely use a matrix because it is explainable. Because we could go for probabilistic surrogates. That would be way more complex. That would take into account all the non-linearity, of what we're looking at, but we don't purposely because we want to preserve explainability. And what we've seen is that when we're bringing our technology to a new nuclear plant, we really have two kinds of reactions, speaking about the human in the loop. We essentially, and there's a big generation gap there. We essentially see people who just don't want it because they are opposing the experts and the AI, and they say this is getting my job. And this is what we need to diffuse as much as possible. This is a reaction that we're trying to avoid as much as possible. We're trying to say, hey, it's not you against us, it's us together. And it is really difficult, and I have many, many examples of nuclear plants where you're bringing the tool, they say, we see the value, we understand how it can change the way we work, we just don't want that change. And then you have the other way, where people lack expertise, and they're like, oh my God, this is giving me the easy answer. Awesome. And that's problematic as well, for an obvious different reason, which is, no, you need them to also build the skill set to keep understanding the status of the plants, to be able to criticize what's coming out of the AI. And that touch another concept that, to me, is really the big paradigm shift of AI at the moment. It's less and less about the technology and more about the user experience. How do we bring a user experience that preserve the expertise of the people that will be using AI? And the technology, okay, it's getting complex, but it's also getting invisible. Because more and more it's in the back end. More and more you're just focused on what is the question I want to answer, what is the job of the person that I'm addressing, and how do I merge those two constraints?
Please.
Okay, so you threw red meat to the tiger here. This is one of my favorite. That's an American statement. People get excited. So in almost every boardroom across the United States, or not the United States, across the world, there's excitement around generative AI. All of the board of directors, the CEOs, the leaders have said, generative AI is everywhere. We must go deploy generative AI. Like, that's the statement. So then it goes to the CEO, and the CEO says, okay, we have to deploy generative AI. They look at usually their chief information officer, their CIO or their CTO, and say, we must go deploy generative AI. So what usually happens is, and since Microsoft's not here, I'm going to pick on them, every large enterprise has Microsoft as their Word, Excel, and they have free AI through Copilot. So what ends up happening is all these different organizations get told, go deploy Copilot, it can do all of your work, it's incredible. And the challenge you face is when you have these broad large language models that are made for general business purposes, and you then try to insert them into mission-critical applications such as nuclear power or healthcare, you quickly realize the models, they hallucinate. You wouldn't ask them the population of Venice. So as a result, I think many people have had a negative first experience with AI in their professional environment. So that's just a general state that I think we're running through. To answer the question more specifically, how did we make sure that our technology would be more reliable? It is all benchmark, mathematics, trial and error, testing, and validating the results. So when we started a couple of years ago, I thought this was going to be an easy journey. Generative AI and nuclear, we're going to be what's called a wrapper on top of ChatGPT. I just built a user interface on top of ChatGPT. Give me your nuclear data, bada boom, bada bing. I'm printing money. It's going to be incredible. Quickly realize nuclear documents, when they get thrown into these large language models, the hallucinations occur an incredible amount because nuclear is its own language. I mean, there's acronyms for everything. Sometimes acronyms mean different things at different plants or different parts of a plant. So you have this big problem with nuclear being quite literally its own language. So to solve that, we leveraged partnerships with the Department of Energy in the United States. You saw the Genesis mission. We are part of that. We have a partnership with Oak Ridge National Laboratory. They have a supercomputer called Frontier. It is one of the fastest supercomputers on the planet. We went and we downloaded, in partnership with the Nuclear Regulatory Commission, 53 million pages of documents, basically everything that was publicly available from their website. With their permission, we didn't just screen scrape it. We took that data set, and with Oak Ridge National Laboratory, we got access to Frontier, and we trained what's called nuclear-specific sentence embedding models. Sounds really fancy. What it really is teaching artificial intelligence how to understand nuclear words, nuclear terminology, and context behind that. So by leveraging that, especially for our use case of search-based capabilities, if you don't understand what the words mean, you can't bring the right documents back. So that's important for the foundational level of search. When you then move into more generative, talk with documents, and you're introducing the large language models into the equation, if you look at nuclear, nuclear, we don't have a lot of benchmarks that are publicly available that everyone can look at. So an example I'll give is when ChatGPT 5.1 came out, you see all of these big notifications that ChatGPT can now pass the medical boards. It's smarter than a doctor. It can pass a physics exam. There's all of these tests, for lack of a better term, that have been developed. In nuclear, we don't have any of that. When Google Gemini just came out, version, I think, 3.0, is that better than ChatGPT for specific workflows? What about other models, DeepSeek, et cetera? We don't know which models are best suited for different use cases. So to solve that second problem, we struck another partnership with Idaho National Labs, again, leveraging the infrastructure we have in the United States with the National Lab System, where we're actually building out these benchmarks. And we're actually going to make all this publicly available because we need to know out the gates, without any fine-tuning, training, or optimization, how do these models perform, so we can then determine where they're best applied in the nuclear power space. So long answer to your question, it is all about scientific rigor, it is about benchmarking and continuous improvement, which are, I think, key themes or concepts in the nuclear power space.
Well, thanks, Lydia. Sid, you want to build on that?
I mean, can I just quickly say, it seems like a common theme here that bringing the human in the loop is really important for establishing trust. I mean, I think we all very strongly agree on that. And I think that's echoed by the fact that I think amongst different professions, trust is highest in AI, or one of the highest in AI amongst doctors, right? And that's because they've been using AI for decades, and it's been visible in their work, right? It hasn't been an invisible thing working in the background. For example, for AI in radiology or different scans, AI said, hey, I think there's something wrong maybe with this lung, with this organ, but you double check, right? And so it's been visible, it's had human expertise in the loop, and people have been brought along with the journey. And I think that established an immense amount of trust. And I think doing that, replicating that success for nuclear is going to be really important.
No, thank you. And I think we're talking a little bit about demystifying AI. And I think the word demystification is something that many of us in the nuclear field are also very familiar with. And so we're talking about demystifying two sectors and bringing them together, basically, right? So the job is real. And you've shared already some examples. Thank you for on where AI has already improved performance and safety at NPPs. What lessons have we learned from some of these early applications? I'm coming back to early applications that could guide us for future deployments, the AI in nuclear. Does anyone want to jump in first? Very polite.
Well, I just went, so why don't you go?
Okay.
Okay.
So many lessons learned. So I will pick my battle, and I will choose two, cloud and data, which I think we generally agree that those are two major topics that we could spend a panel on. Data first. Data is scattered all over the place. Especially on nuclear plants, you have like data that is handled at the local level, some other that at the national level, some of different criticality, some not everybody is educated to cloud the same way. It's a big mess. So accessing the data, just accessing the data, is the first struggle on every AI project. And it's not a struggle to minimize because it can be a deal breaker. Like it can literally provide you from doing anything at all. So everybody, all over the place, everywhere we go, every utilities, every country, they have a data strategy to try to create those data lakes. But not everybody is honestly well educated to how to manage a proper data lake, how to bring API, how to treat data as an asset, understanding the criticality, understanding who can use it for which reasons. You know, like there's a real governance that utilities need to have over data that will actually facilitate the access to the data. For instance, and leading me to the question of the cloud, most of the persons who don't want to go in the cloud with us are people who are just not educated to what cloud means and are not able to audit what we're doing in the cloud. If you go to the most advanced utilities, they all want to go to the cloud and they have the skill set to get there. So there is a consensus that cloud is cheaper and provide you with like more calculation power, but it's a daily struggle to explain, to address the question of cybersecurity and to get people to move in the cloud. In that regard, we see in many different countries initiative of building sovereign clouds that I think is very welcome for the nuclear industry, and that's definitely something that needs to be pushed forward because it reassures utility. It's just as simple as that. It gives them the feeling that, okay, this cloud is safe. And that's already one step, because you cannot realistically bring the best use case of AI on-prem. At least that's my belief. I don't know if you agree on that. I would be curious to have your views on that. So I would say data governance, strong API, strong modularity on data, having also a strong education on what is possible to do in terms of IT, to secure a flow, to leverage the cloud, all that together. It seems easy when I say it, but like it's never, ever what we find. Like every time we go from zero and we engage in discussions over discussions over discussions, and that is like, you don't have the data, you don't have AI, end of the story. Like you don't have to go much further, you know, that's the ground base. So that would be my first struggle.
Thank you, and I think when you talk about access to data to improve safety of NPPs, that's great, but of course, the cybersecurity angle, the safeguarding angle, that's that interface that we also need to, that we juggle with on a daily basis without AI, and so now we're putting AI into that conundrum as well, right?
100% agreed, and that cannot go without the proper cybersecurity skill set, services, demonstration, the penetration test of your cloud, everything that goes along with deployment in the cloud. But so that's definitely part of it. And back to what I was saying, that's part of the whole education that everybody needs to have so that it becomes easier. Because right now, there are many places where you go, you say cloud, and people are just like, ugh. Mm-hmm. They don't even want to hear about it.
Well, and I think, a lot of people also care about their IP, right? So you're trying to do projects. We mentioned earlier on some panels about how we're going to build nuclear faster and easier as we engage AI. And yes, we will, and that'll be a part of it. But you do have to be thoughtful that, if you're a technology developer, you don't want all of your details, out there just for anybody. I mean, that's private and important, material for you, right? So the whole IP and how to deal with that. In fact, I'll go to Trey again because I feel like we started a project, and for 6 months, I think the only conversation was around IP and structure. And I told him, hey, we've made great progress. And he goes, you do realize we've only been now working on this since August. Now, in my mind, we've been working on it since probably February or something. But what he's saying is, no, you didn't get started until you got the structure and the IP figured out. So.
Oh, yeah, I mean, since you set me up there, I'll dovetail on that. I think 100% agree with everything stated. So you stole all what would have been my first answer, so I have to go to answers, 3B, 4B. So first, I mean, justifiably so, nuclear as an industry is, a very conservative and in some cases litigious industry. There are a lot of lawyers. I've never had so many lawyers as part of an early stage company. My legal bills are way more than I ever expected, but it's understandable because of, at least the United States, export controls. Like losing that data could have critical ramifications, and I come from healthcare, so definitely appreciate all the healthcare comments, but nuclear from a security perspective, from a conservative, when it comes to the cloud perspective, I mean, it's on the very end of the spectrum in regards to not wanting to go to the cloud, aversion to the cloud, and a big part of that is because of the legal risk associated with that. This industry, justifiably so, does not like to take risk, which makes a lot of sense because, risk introduce potential problems or challenges. So I'd say, kind of some lessons learned beyond cloud, on-premise, APIs, data integrations. I do think just understanding there will need to be a certain amount of time, resources, and dedication to getting contracts signed, IP agreed to. And it's not just with NEI. The first power plant we engaged with, Diablo Canyon, it took us longer to get the contract signed, the MSA, cybersecurity review, than to actually implement the project. And that's not a knock on them. That's just the world we live in. And the challenge that will be introduced, and I think there's a lot of great examples where, Westinghouse and what they're doing with Google, I mean, How cool is that? Like the fact that Westinghouse, one of the leading providers, is up here, thought leadership position, Google's by their side. But when you build a reactor, I mean, you got to bring in your EPCs, your engineering design, your supply chain. Everyone's going to have different systems. So just mentally preparing for the legal cost to try to get some of those projects through is going to be something we're going to have to address. I know supply chain was brought up earlier. So I'd say that's one. Going a totally separate direction. One of my big lessons learned when we were first starting with the nuclear power plant we partnered with, I went on site, you know, I'm from technology, so I get excited, and I would go talk to all these nuclear engineers, and I'd say, hey, we're starting to design and build generative AI to make your life better. It's going to be incredible. And I'll never forget, there was one engineer, I won't say his name, he had worked at the power plant for like 50 years, like, and exactly how you'd imagine, like, you know, wore suspenders and had a big beard and mustache, and he kind of folded his arms in the meeting and frowned his brow a little bit. He's like, I'm not using AI over my dead body. And I was just kind of like, oh my God, how do I even respond to that? So the guidance and the feedback I received, and I can understand this, AI, especially for someone that's worked at a plant for 30, 40, 50 years, is not used to changing the way they do their job. That could sound scary because maybe what they know about AI is it's coming to take their jobs and it's going to put them out of work and it's going to take over. I mean, there's a lot of negative news in the news cycle around AI, a lot of positive, but also a lot of negative. So the thing that we learned is not to lead with AI. Not to come and say, hey, we're bringing in AI to make your life better. Instead, focus on the problem. So for this specific individual, a great example is that person had just spent about a month gathering 6, 7 documents from their internal systems. So the next time I met with him, I repositioned it as, hey, what if we made it easier to find these documents so it could happen in minutes versus months? Would you be interested in that? To which I was hoping he'd say, absolutely, that's incredible. He said, okay, I'd give it a chance. So we made progress, but I think that the big lesson learned is the AI isn't the answer. The problem solved by the AI is the answer. So it is a change management exercise as you engage with your large organizations. I don't think this is a unique problem in the United States. I think worldwide, as you're engaging, especially in plants that have been operating 30, 40 years, making sure to meet the individuals where they're at and speak to them in the language that they can understand to drive the outcome that makes their life better. Because really, that's what AI is all about. It is about taking out the drudgery of what this individual does day in and day out so they can actually spend time doing high-value engineering work, which is really what they want to do anyway. So I think big lesson learned, be ready for a lot of legal cost and back and forth, and then separately, keep the human factors element in this discussion.
Sid, I think I want to put an extra question for you just because of your background, but you can also build on this. Is it safe to bring the mentality of a startup, of build and break fast, to nuclear, in particular when it comes to AI?
Yeah, that's a really good question. I mean, so as a startup, we often say, you know, we're agile, right? And yeah, we operate fast, and I guess most other startups would say, and break things, right? I'm going to go out and say I think that mentality, the last part of the mentality for a lot of use cases is just not okay, right? Whether you're a startup or whether you're a big firm. Sometimes we really do not have the option to break things in nuclear. But there are loads of different areas where we can, right? I think a lot of people sometimes think, oh, nuclear, it's a really sort of scary bureaucratic sector, a lot of safety, a lot of risk. Yes, in a lot of areas. In a lot of areas, we might be trying to make processes more efficient, but it's really not the end of the world if a large language model gives an answer that's not correct, right? And so I think a lot of it can be about finding the right use cases where you're allowed to sort of break things and be a bit more free. But I'd also argue just because you move fast doesn't necessarily mean you have to break things, right? And I think from our perspective, one big learning from things we've done is sometimes the nuclear sector can be a bit slow on innovation or driving innovation. So you think, for example, I mean, my background's nuclear fusion, but you also think of sectors like space, SpaceX, things like that. you move fast and break things because there's really no other option. You innovate because it's do this really complicated thing or fail. And in nuclear, I think there's a bit more of a difficult way to define the innovation incentive, because the way we're doing things works. We can build power plants. Maybe they're not the most cost-effective sort of energy source out there, but we can build things and they're safe. And so we find definitely, working in the UK anyway, that sometimes we do a proof of concept project, it's really great, but then people go, changing that to the standard, the default way of doing things, actually, what do I get out of that? Because right now the regulators are satisfied by the work I do. Right now the work sort of chugs along, I win my contracts, I make my money. What is the real driver for that innovation for completely changing the way you do things? So I think that's one thing that I'd like to see maybe improve in the future in the nuclear space, is how do we incentivize that accelerated innovation, maybe taking lessons learned from other industries where innovation is much more necessary.
Okay, well, thanks for that. And if we pivot towards the future, it's a good segue. As AI becomes more integrated into nuclear systems, and we've talked about a number of ways in which we're seeing that happen, what are the biggest opportunities that you'd see? I'd like to ask all the panelists this. And also, in parallel, what are the measures that we need to take and make sure are in place to manage the risks that are related to data security? That's what we've been talking about, the reliability, the human oversight, and that comes back to something we were talking about in panel 1 about workforce planning. So let's talk about the opportunities.
Yeah, I guess I would just maybe just step back for a minute and just say, like, what are we going to look like, 20 years from now? And, just hearing some of the panels that happened earlier today and some of the keynotes, I mean, I can just imagine that we're going to have power plants that, you can imagine even today, you have some plants where you have a group of people that are sort of monitoring, a power plant, if you will, from afar. I can just see a lot more of that. And so instead of needing, a bunch of engineers at every plant, you can put a bunch of engineers in one place, and you can be sending them a lot of data from a lot of different sources, and they're looking at the trends across different systems, et cetera, and they're being able to benchmark across several different things. So to me, it's about, you can imagine that this is around collecting and synthesizing the data so that your mind is being brought to the problems, the challenges, the negative trends, and instead of having to sort of sort through a lot of that maybe in a more manual way. I could even imagine some of the smaller, the microreactors, for example, could we have these operating in some place and, maybe that's it. They're operating there and I'm monitoring them from afar, right? They're driving themselves, so to speak. And so I guess, I would just step back for a minute and say that is the art of the possible, and then look at where we are today, and you can say, what are the steps to get there? Well, first of all, we're going to have to build an awful lot of trust in the systems that we're talking about and the cybersecurity, that we're mentioning, et cetera. But there's just huge potential for us being able to really, I would say, kind of have a whole different fabric, if you will, for these power plants. But it's not going to happen overnight. It's not going to happen overnight. It's going to happen where these systems are, really tried out and ensured through all the different testing that's being talked about here, and you gain that confidence, and trust. But I think it's a huge potential. Even earlier today when we heard from Westinghouse and they talked about, well, you had your schedule laid out this way. Any of us that have run complicated refueling outages, you realize that was the way on paper it looked great, until the widget doesn't show up, whatever that widget is. And so you can't do the replacement of that pump right now. And you don't want all those people around not doing any work. And so you have to redo your schedule. Well, having something like a lot of AI intelligence built behind how to, sort of best look at that and redo it. I mean, there's amazing opportunities. But again, it's not something you're going to put on autopilot and just push a button and say, good luck with that. So there's a lot of work, I would say, over the next several years to ensure that, that we build a structure that creates the trust and the transparency that we need.
So, future opportunities? Aurélien?
It's easier for me to speak about the constraints than the opportunities because that's literally my daily job to deal with the constraints. But I will still speak about opportunities. Obviously, the first opportunity is the added value that we bring to the nuclear plants themselves. And I can give you 2 examples that I think in the near future will be achieved and that are not yet the state of the art, that are not yet achieved. The first one I will mention, I will be very accurate on that example, mentioning what we're doing with the Canadian nuclear laboratories in Ontario. We've built a test loop to try data reconciliation validation technique in order to eventually do a safety demonstration to do a power uprate of up to 20 megawatts. We were granted a DOE grant to support that research in the US as well. We have an office in Alexandria, Virginia that is doing the job there. And that is pure additional megawatts that is almost free, provided the fact that we're able to do the safety demonstration, which is a big provided. But still, it's pretty costless, and it's the cheapest way of doing a power uprate. And by the way, if I go there, I also think that we should value our existing fleet a little bit more, because when I speak to utilities, all the money, all the investment goes to SMRs, new build. That's wonderful, not saying otherwise. But we have an awesome fleet that is running that also needs some care and some love. I'm just saying that. So back to the opportunity. So that opportunity is clear use of AI to do a power uprate of 20 megawatts per unit worldwide. So you add that up, you see it's like pretty much free compared to the added value. I think it's the cheapest megawatt hour you can think of. Second opportunity, something that we're putting a lot of research effort right now at the moment, is merging machine learning and probabilistic risk assessment. So what does it mean? I explained earlier that the data itself is not enough on a nuclear plant because the system is so complex and you don't have that many data to actually be able to properly understand it. So you need to embed expertise. And the expertise that we've not been able to embed so far is taking all the theory of probabilistic risk assessment, so the reliability theory, and put that into the real-time monitoring systems. So far, it's 2 separate words. Like, they don't speak to one another. But when you get there, you have all the theory of how machine breaks into your real-time engine that is able to detect the first steps of that failure. That becomes very powerful. We're not too far from reaching a moment where, in my domain, that is online monitoring, we can literally tell you everything that is possibly said about the status of the plant. And you mentioned earlier, I think, Sid, you mentioned the importance of mastering uncertainty. We can also say what we cannot say, which is also of interest. Many times, we go to customers like, we want to know what's happening on that valve, and we're like, it's not possible to know, because there is no data here. There's no sensor. Like, there's just like, how do, it's a blind spot. So I think that we're not too far from being able to fully advise utilities to say, what are the spots where you need to put the sensor? What is the diagnostics that you're getting out of that? And get to really the most comprehensive diagnostic possible in online monitoring with very high level of reliability. And the big question is how all the experience and all the expertise and all the technical documentation that exists is embedded in the AI. That is the challenge. I will solve it.
Yeah, and I think that building trust and admitting uncertainty is a huge component to trust building, whether that's with people or then, with AI as well. So
it is very important to be humble, to understand what you cannot say, and to be extremely clear about it. There's nothing worse than, as you were mentioning earlier, like a false assertive result. That destroys confidence totally. Yeah. So you never want to go there. So yeah, and like if we speak about LLMs, I have one use case of LLM in the full Metroscope suite. It's just to question our user guide, because this is like, okay, you can handle a few hallucinations. That's fine. This is where like it doesn't hurt you too bad if they're asking in a prompt, okay, what happens if I press that button? That's fine. But so far, we've not been able to use LLM for anything, I would say, more serious than that, just because of the limitation that we discussed. So once again, in the domain that I know of, which is online monitoring, eventually we'll reach a moment where we can tell you everything you need to know about the plant. The question then is, what do we do with it? And that is a question for the regulatory, that's a question for the utility. There's another big question that is the market shifting? Because I don't see so many new actors in the market in regards to the revolution that is happening. And I think that the software editors, the AI editor will grow, will be stronger and stronger, and that will ask a big question about who has the knowledge, who has the data, how do we split, how do we perimeter this whole market with those new actors that are coming and that are coming big, because they are necessary.
Yeah. Thank you. So, Drake, future opportunities?
I want to start with a quote, because I want to make sure I get this right. So, our vision is simple. We want to create a factory that can produce a gigawatt of new AI infrastructure every week. I didn't read that wrong. Every week. And that is Sam Altman, September 2025. For those who don't know, Sam Altman is the CEO and founder of OpenAI. So when you hear that, I mean, it just, for us in the room, it just is almost unimaginable. Like the idea that we are going to build an AP1000 every week, that's the one I know the best from Westinghouse, and we're going to tie it to this giant AI data center. I mean, it just sounds just unbelievably ambitious. But when you step back, the reason for this, and Sam Altman, he's a genius, he's brilliant, is very much tied to what I see up on the walls. So atoms for peace and development. And when you think of the origins of IAEA and when nuclear power was just coming into market, there was a similar vision, which is abundant energy for the world. And energy is the baseline of society. If you can get energy in emerging countries, and energy can come in and just solve so many problems for society, everything from desalinization, food, etc. AI has very similar ambitions. In that same blog post, the reason Sam wants all that AI, and it's not just Sam Altman, it's many of the leaders in the AI labs, is there is a true and genuine belief that we are unlocking intelligence and knowledge that will do things that's unimaginable. We're talking about discovering cures to disease, curing cancer, solving climate change, things that are just unbelievably exciting. But you have to step back and realize where you are today. And I think that is why this conference is so critically important, because in the room, and when you go back to your nuclear power plants or your engineering firms or your EPC, there's a reality that nuclear power is incredibly complex. It is incredibly challenging. There's a reason that the Vogtle projects went way over budget, took longer than expected. It's not because of the lack of ambition. It's just this is very challenging, and we have to get it right. Nuclear is an industry where we cannot make mistakes. We have to be accurate, and this is very personal to me because I live 10 miles from Diablo Canyon Nuclear Power Plant. The reason I'm able to come here, and I'm a father, I have a 10-year-old, I have a 6-year-old. If you are a parent, you will understand all you do is worry about your kids all day. That's like my job, just always worried about my kids. One thing I am not worried about is Diablo Canyon. It runs exceptionally well, and that is not by accident. It is not a coincidence. It is because the IAEA holds everyone to high standards. It is because the NRC, the Nuclear Regulatory Commission, makes sure they operate efficiently and safely. So we have this world that we live in right now, which is incredibly exciting. Everyone in this room, we are at a point where nuclear power, which has the potential to achieve the goals of Atoms for Peace and Development, is intersecting with AI, which I will argue is an equally powerful force. And as a result, there is just tension, there is friction, there is messiness. And the next few years are going to be incredibly challenging. Like, there's no way around it. And just digitizing the documents and getting search to work, that was way harder than I thought. So we are going to be in this period where it is just going to be grueling, we're going to grind it out, but I have faith in humanity, and I have faith in society, and I believe we are at a point where through leveraging artificial intelligence, the vision of what nuclear power, what it was, what it is going to be achieved. I'm not going to give you a time. I'm not going to say it's in 2 years, 3 years, 5 years, but I truly believe in my heart of hearts, the missing building block, the element that was necessary to unlock nuclear power is now in its early stages in AI. So my vision is, in the next decade, I don't know if it's 10 years, 20 years, 30 years, we're going to succeed in this, and I think it's going to make the world an incredibly better place, and I think it's going to help IAEA, achieve its goal of atoms for peace and development. So I'm incredibly bullish, but also working exceptionally hard and based in the reality of we have a very, very long way to go.
Thank you.
Really well said.
Awesome vision. How do I follow that up? My God. Yeah, I mean that's just. I think that really highlights why we're all here, right? I think we all see nuclear power as being that available, sustainable energy for everyone, which is just an amazing dream. In terms of what AI looks like in nuclear in the future, I really love everyone's vision on the panel so far. What I would add is I see real potential in what ChatGPT's sort of success was. And I think its success doesn't come from the fact that it did something complicated or that it was useful or that it generated value. I think, for me, the biggest reason it's exciting and has generated this wave of AI is because my grandma can use it. Not specifically my grandma. I mean, sort of everyone can use it, right? In fact, I'm not sure my grandma does use it, but anyway. I think there's real power in exposing technology to people, democratizing technology, and really getting more people exposed to it. I mean, AI's existed for decades and was doing really impressive stuff for decades, right? You look at sort of like reinforcement learning for playing chess or AlphaGo. It was doing really cool stuff. But the fact that then there was a tool developed by AI, with AI, that everyone on the planet knew how to use and could get value out of, that's crazy, that's useful, and that's a really exciting thing. And I hope that happens more, not just with language-based models. So I think our vision of the future at DigiLab for technical domains like nuclear is that we can bring everyone on the journey of AI and not just have language models next to them, though obviously that's very important, but to have quantitative technical models enabling what they do day to day, and having that be very exposed, very visible, but very easy to use, very trustworthy, and have them trained and come along with the journey such that everyone becomes, mini AI experts, just like how now, I mean, some people put it on their CV, but everyone's kind of an expert in Word these days, right? And so that's our vision of the future for AI and nuclear, is that everyone's their own little AI expert, and everyone has some input or some impact in that journey.
Well, thank you for that. And I think this has been a really energetic conversation. It's been delightful to listen to you. So I'm going to ask you to be short now in the observations and the recommendations, because I want to make sure we're on time. So if I can ask each of you, as we did for panel 1, to first share an observation on AI in the nuclear space and build on the conversation today, what you heard earlier today. Who wants to kick off? Maria, would that be okay?
Sure, yeah,
Thanks.
happy to go first. I don't know, we've heard so much about change. Maybe I'll just flip the script for a minute and say it's easy when we think about things like AI and how much the potential is for change, but I think maybe we should step back and say, but what's not going to change? And I think what's not going to change is our commitment to safety, and what's not going to change are, the focus on our workforce, which is the bedrock, for this industry. And what's not going to change, is our appetite for innovation. I've worked in these power plants for over 30 years, and on one hand, you'd say, yeah, well, the technology hasn't changed so much. But, honestly, when you're in the plant, there is a lot that has changed. You go to digital controls and many changes to a variety of different systems. So there's already a thirst for change and improvement, I think, at each of these stations. And again, I know that's not going to change. We'll just maybe do it in a different way. So I look at it and say, with AI at our fingertips and all of those principles that we know and we hold dear, I think the possibilities are amazing.
Sid, you mentioned chess earlier. I'm a chess player, so I would just say AI solved chess. Literally, it solved it. Yet it didn't kill the game, it made it more competitive. And I think this is exactly what's happening.
Yeah, so I think so many incredible comments have been shared earlier. I don't want to rehash a lot of them. I think one thing that hasn't been stated, and it's not AI related, but I think it's worth bringing up, is as an industry, we're all in this together in nuclear power. And the reason I ended up joining was because Diablo Canyon, which is my local neighborhood nuclear power plant. That's why I named the company Atomic Canyon, an ode to that facility. It was supposed to be shut down. Yeah. It was supposed to not be operating right now. But alas, there are a lot of really great people that stood up and advocated for that facility. And us in the room, I wouldn't want to say echo chamber, because that's a little too strong. There is an element of everyone here loves nuclear. Like, we all believe in nuclear, we're all in. I got a rude awakening my first Thanksgiving when I entered nuclear, and I went and told family members I'm going into nuclear power. In the US, we had this TV show, The Simpsons, where there was green ooze and three-eyed fish. At least in the United States, for many people, that is still the belief of nuclear power, that there's pollution coming out, and things as simple as it is a carbon-free source of energy. I know we all know that, but I think many people take for granted that the general public is woefully uneducated about nuclear power. So I'd be remiss being on the stage to not share. I think we all have a responsibility to embrace this technology of AI and figure out how to make it work. And there's a great vision of where it's going to go. It's super exciting. I think safety, Marie, I'm so glad you brought that up. I think that is the foundational layer. We cannot ever lose sight of safety. Like, that is non-negotiable. Like, no, absolutely not. But the next layer is the continued evangelism of our industry, because this is an incredible technology. And every time I've had a rational, sometimes there's irrational, but every time I've had a rational discussion with someone about why I'm dedicating my life to nuclear power, they get it. I mean, they understand. Little Diablo Canyon, 2 gigawatts of power, 10% of the state of California, world's fourth largest economy, in a city with 40,000 people. So again, not AI related, but as we go forward, safety, like, we all have to take the pledge. We can never take our eyes off safety. And I think secondarily, continuing to evangelize to the world, to our local neighborhoods, how incredible this technology is. And as AI comes in, it gets even scarier. It's like you're crossing AI and nuclear, probably the two scariest things you could ever imagine. Educating people that we're not out saying AI should run every single nuclear power plant. Far from it. We are saying there are a number of steps and there are a number of processes that AI can come in and help make nuclear even safer, make it more efficient. So I think making sure we all have the right talking points and we continue to evangelize, because again, AI and nuclear share so many characteristics. I'll end with, it's funny, in Wisconsin, they're considering reopening another nuclear power plant, Kewaunee. It's actually public information. There was an article reported about it, and they're going to tie it to an AI data center. And guess what? The local people had no problem with the nuclear power plant reopening. They had issue with the AI data center instead of the nuclear power plant. So I bring that up because as AI takes off, it's going to get more controversial. Introducing AI into nuclear is going to be controversial. I think the onus is on us as industry to make sure we have the thought leadership positions, we have the education, and we're ready to have the rational discussion on why it is the right time to bring AI into nuclear and how it supercharges the industry, and also what it's not going to do, such as it's not going to run every single nuclear power plant or anything that extreme. So I think messaging and evangelizing will be of critical importance in the next couple of years.
Thank you. Sid?
Yeah, I love that point about evangelizing. I'm just envisioning sort of Terminator crossing over with the Simpsons episode, right? The robots control the toxic ooze. For me, one observation, one really strong observation from this panel is just how little we've talked about the need of technology improvements, and more highlighted the things that need to go around that, right? Things like building trust with the people that are going to use them, the people that are going to regulate them, things like the environment that goes around AI, data centers, data availability, ontology, structure, that kind of thing. Things like public acceptance. And so for me, that's a huge observation, and I think we've explored it rightly so, that we're at the stage where we have really good models, really good methods. What we need to do is that big integration acceptance piece. That's what really, it seems like the consensus is. But please correct me if I'm wrong.
No, that was good. Thank you for being concise, because I know we're running out of time, but I do want to hear everyone's recommendation, since we're asking an observation and a recommendation from every panelist. I know I've heard some recommendations weaved into your observations, so if you've got a couple sentences on...
I guess I can start with a recommendation. I think we do need to come out, NEI has some, and probably we should team with IAEA, but we came out and issued a recommended practices for artificial intelligence in the nuclear industry. And so I do think that that is something that is needed and necessary at here's the best practices, so to speak, especially an organization like IAEA, because you have such breadth in terms of, membership. So I do think that is something, just hearing all of our conversation here, I think that's worthy.
Noted. Thank you. Aurélien?
I would just say that the concept of AI is to make everything easier, but actually what is at stake here is that we keep the effort. We don't go the easy way through AI. We keep the effort of educating everybody to what are the different technologies behind AI, what does it mean in terms of data management, what does it mean in terms of cybersecurity. So the effort that is doing by the agency in gathering people around those technical topics all across the world is so tremendously important, and we actually need to all acknowledge the fact that we don't know yet the skills that will be necessary to run a nuclear plant in 2040, We don't know. There will be like way more data scientists than we have today, maybe, or maybe not. I genuinely don't know. But what I know is that we all need to be educated to what is AI, what are all the consequences, so that we can make like a fair decision making. And in that regard, there's no easy way, because we need to understand it, and we need to keep the effort of gathering, speaking about it, building guidelines, having technical discussion, putting expertise at the center of the whole thing.
Thank you. Jay?
So as an entrepreneur, I messed up the order and I gave you my recommendation
I thought you might have been giving us the recommendation.
And now I have to go back to my observation, but it's okay, I got my observation. So I think one, just it hasn't been brought up today, and I think it's maybe stated without being stated. An observation is to really understand the size difference between big tech and between nuclear power. I'd love to give some numbers, and I just pulled these this morning. They might have been updated. So NVIDIA, their market capitalization, kind of the enterprise value of the company, is $4.3 trillion as of earlier this morning. Microsoft is $3.6 trillion. Google just leaped Microsoft $3.8 trillion. They had some great news about their TPUs, another version of GPU, bumped them up. So those are exceptionally large numbers. I think people lose track of what does $1 trillion actually look like. So let me help give some context. In the United States, the largest public nuclear provider is Constellation. Constellation's enterprise value market cap was $117 billion, or approximately 2.7% of NVIDIA. EDF in France, I clocked them at $135 billion, which is 3.1% of NVIDIA. So I state that because, look, big tech is here. big tech has made it very clear they are going to be engaged with nuclear. They're going to help us build plants. A lot of comments are coming from big tech industry. Don't forget, as you're entering these engagements, that NVIDIA on any given day fluctuates a constellation in value. Like literally, they will have an announcement, the stock goes up 2%. That is the entire enterprise value of and Constellation has been on a roar. Their stock's like 3x over the last year. So I think that is important because I think it cuts both ways. Like I've said this before, I think big tech is like interested and they're kind of dating us in the nuclear space. I don't know if they're ready to be married to us, because when I was in healthcare, I used to think, wow, big tech's really come into the space. They're investing 100 million here, or 50 million, 200 million there. And then I saw big tech get into healthcare. And when that occurs, like Oracle came and spent $30 billion to acquire Cerner. And Amazon went and acquired One Medical for many billions. They just started buying doctors' offices. So I would just caution, as big tech enters, we haven't seen anything yet. Like when big tech is really ready to come in, the idea of, we need $100 billion of investment, that's less than 1% of the company. And I can tell you this without a doubt, energy is the bottleneck. Like the reason they're all here, like what does big tech want? I know that's the previous panel. They want every single nuclear power plant yesterday. They want gigawatts of power as quickly as it can be produced. And look, when big money of that scale starts to enter this space, I know we're excited about the recent developments. This is the tip of the iceberg. So back to the earlier point, the intersection of these two industries is going to be incredibly exciting, but we have a lot of work to do.
Thank you. Final recommendation, Sid?
My recommendation would be similar to other panelists, specifically for the IAEA and for us here, is to, agree on stuff, to facilitate sort of agreement, best practices, use cases, things like this. And even one thing that was sort of subtly mentioned, but I'll highlight, is value generation from these use cases, in that you see a lot of AI applied in many different parts of the world with a sort of very murky or immeasurable actual impact. And if we can get together as an industry and say, this is a really fantastic use of AI in nuclear, everyone and their grandma should be doing it. We achieved 5x improvement in, lead times for a component or construction time or design time for something. Just so that we can all agree, that's a great use case. That's how you develop trust for that use case. That's how you sort of integrate AI with that use case appropriately. I think there's a huge opportunity to come together more and to document these successes and nuances. Great.
Well, thank you so much. I would like to thank all of our panelists for a very dynamic discussion to end the day. It's delightful, actually, to end on with the dynamism that we've had. So we've seen how AI is already making an impact in nuclear operations, and how its future applications could transform safety and efficiency and innovation. But these discussions remind us that technology alone isn't enough. And we need the trust, and we need the collaboration, we need the transparency. These are all topics that have come up: accountability for robust safety, security, safeguarding, which will all be key as we move forward. So I will ask the audience to stay, because I have a few more announcements on the rest of today and tomorrow. But I would like to thank the panel and ask you to join me in applauding. Thank you. Thanks, Mary. Thank you.